Okay, so now we're going to start with the sine function. And we're going to try to restrict its graph so that it's one-to-one. So sine, if I draw a full period, looks like this. So minus 1, this is 1, minus 1. So it goes through here, 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 and here, and it looks like this. Okay. I'm also going to need, you'll see, so this is pi over 2, by the way. I'm minus pi over 2. I'm going to need the part of the curve that's to the left of the y-axis. X-axis, y-axis, yes, to the left of the y-axis. Okay, so I want to achieve two goals. I want to choose a part of the curve that's one-to-one, okay, that satisfies the horizontal line test, but I also want to cover the entire range, okay, of the function. So, for instance, just choosing that little part, okay, that's one-to-one, but that's not covering the entire range of the function. Now, to do this, so the most obvious way to do this is to pick this part of the curve. You start here and you end up there. And if I choose this part of the curve, okay, you can check that because it's surely increasing on between minus pi over 2 and pi over 2. It satisfies the horizontal line test, and it covers the range from minus 1 to 1. Because this guy here, that's pi over 2, 1, and this point here, minus pi over 2, minus 1. So this is where this is how we're going to restrict the graph of sine. So the restricted domain will be from minus pi over 2 to pi over 2. The range is going to be just like for sine from minus 1 to 1. So this is for the restricted function. That's in orange, highlighted in orange on the curve, right, on the graph. If I want the inverse function now, okay, the inverse sine function, okay, its domain will be the range of the initial restricted function, and its range is going to be the domain of the restricted function. Because for the same reason that if I have AB on this curve, I've got BA, so the roles of X and Y are changing, so the roles of the domain and range, the values of the intervals of the range and domain are actually being flipped as well. So what kind of function is that? So what I need to do is just reflect the graph that I highlighted across the x-axis. So it would look like this. So actually the graph is not super important, but I'm going to try to do my best to graph it. So let's say this is pi over 2, 1, and pi over 2 minus 1. So this is our sine curve, restricted to the interval minus pi over 2, pi over 2. So that's the part in orange. So it looks flatter because I've tried to draw it so that it looks what it would look like in reality if the scaling is the same along the x and y axis. Now, the line y equals x is, let me add it, this is the line y equals x. So it turns out that this line is completely tangent to the graph at 0 of sine. Okay, so it's not a coincidence that it looks like this line just barely touches the curve at 0. It does. And if I reflect that graph, I'm going to get the graph of the inverse. So maybe actually it's easier first to see where this point is going to go. This point is going to go over here at 1 pi over 2. This point is going to go here at -1 minus pi over 2. And the graph will look like this. Okay, so this is the inverse sine function. Okay, it has a special name, just like log has and ln have their special names for the inverse of exponential functions. So this is y equals arcsine of, let's say, x. It's also written like this, sine -1 x. But now you have to understand, sine -1 is a single symbol. It's not an exponent. This is not an exponent. Now, it's just a single symbol. So it gets confusing because remember that we're using the 2 there. Just this is the same thing as sine x squared. Well, this now is not sine x to the -1 anymore. Okay, so this is not the same as 1 over sine, not at all. So this is its own symbol. So there's no other way to write down sine inverse of x. But if I want to write 1 over sine, okay, or if I want to write 1 over sine or sine of x inverse, that's what I'm going to write. I'm going to have to put brackets around sine. So when I don't put brackets around sine and put the -1 in between sine and x, it stands for the symbol for the inverse function. Okay, so let's do an example here. Maybe actually, you know what? We can come back to our initial problem. If I have theta here, this is 5, this is 3. Find theta. So we know that sine of theta equals 3/5. So in other words, through the function sine, theta is sent onto 3/5. What I can do to calculate theta is, so actually I'm not going to put 3/5 just to make things slightly simpler. I'm going to put square root 3 and 2 instead. Okay, so this is going to become square root of 3 over 2. Square root of 3 over 2. So this is the inverse sine function. Okay, you can put just sine there, inverse sine. So to calculate theta, theta is going to be the inverse sine of root 3 over 2. So in other words, I'm looking for an angle, okay, and such that the sine gives me root 3 over 2. So let's think about it. This is the trig circle. Root 3 over 2 is quite large, right? So this is associated to the point 1/2 root 3 over 2, root 3 over 2 being the y value, right? So the angle I'm looking for, what is that? Well, you'll recall this is the angle where theta is pi over 3 or 60 degrees. Okay. Let's look at some other examples here. Okay, if I ask you what is I prefer arcsine, by the way, than sine. The book uses sine inverse like that, but I prefer arcsine because there's less confusion. You're not going to think that it's an exponent if you write just a word, arcsine. If we want the arcsine of minus square root 3 over 2, okay, well, what are we looking for here? We're looking for an angle, okay, such that the sine of that angle is minus root 3 over 2, and that angle, remember, the angle we're looking for, so the range of arcsine is such that it's between minus pi over 2 and pi over 2. Okay, that's because this is where we restricted the domain of the sine function. So I'm looking for an angle. Okay, where's minus pi over 2, pi over 2? It's here. Okay, it's either here or like that. Okay, rotation clockwise or counterclockwise, where the sign is negative. Sign negative means we're in this fourth quadrant. So we're going to be somewhere here. Which point has the y-coordinate as minus square root 3 over 2? It's 1/2 minus root 3 over 2. And that occurs for an angle of pi over 3 here. So this is minus pi over 3 because it's a clockwise rotation. So the angle we're looking for is minus pi over 3. Here's another example. What is arcsine of 1? Okay, well, for arcsine of 1, once again, I'm in the trig circle. I'm looking for an angle between 0 pi over 2 or minus pi over 2, 0, such that the arcsine is 1. Arcsine is 1 means the y-coordinate on the circle is 1, so we're actually way up there at 0, 1. And here, it's pretty clear that the angle we're looking for is pi over 2. Okay, so an arcsine is always an angle. You're looking for an angle. So here we're looking for an angle such that sine of theta is 1. Okay, so this is our answer.